Okay, so here are the notes for section 8.6, Law of Sines and Law of Cosines. The whole purpose of this section is to be able to solve missing sides of triangles using trigonometry that don't require them to be right triangles. That's the only thing that stinks about SOHCAHTOA is it only works for right triangles. What if a triangle's not a right triangle? What do we do then? Well, given certain conditions, we can use the law of sines and the law of cosines. So, we've used trigonometric ratios to solve right triangles. Now we're going to use the law of sines and the law of cosines. Now for this video, all we're going to do is we're just going to basically set them up. I'll worry about solving in class. I think it's enough work just to kind of get the idea of how it works. And once you can do that, it's just a matter of a little bit of algebra. So in lesson 8.4, you use trigonometric ratios to find side lengths and acute angle measures in right triangles. That's the key. They were right triangles. So now today, we're going to do things that are not right triangles. So the first one is the law of sines. And you can use this to find any lengths or measures in a triangle given the right conditions. So what the law of sines works out as is that if you have a triangle, every angle has an opposite side. So angle A has its opposite side, lowercase a. Angle B has lowercase b for its side. Angle C has lowercase c for its side. And in any triangle, if you take the sine of an angle and divide it by its opposite side, it equals the same thing for all of them. So if I did the sine of angle A, divided it by side length A, I get the same thing as if I took the sine of angle B, divided it by side length B. Took the sine of angle C, divided it by the side length of C. So this proportion right here, okay, is what the law of sines states. Now the only unfortunate thing is, in order to use the law of sines, you have to know two measures of angles and a side. So back in chapter 4, we did angle, side, angle, 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 side. That's what they're kind of talking about here. But the real key is to remember you have to have two angles and one side. If you have that, you can solve for the rest of the triangle. Okay. So the first example we're going to look at is 1A out of the book. It's on your sheet there, solving for missing sides here. So I'm just going to again walk you through the setup. That's it. You can copy it down. We'll talk in class and we'll go over them. So here's this first example here. Now again, what you have to know is that the law of sines is sine of angle A over side A equals sine of angle B over side B equals sine of angle C over side C. So again, just have to have that memorized. Now once you do that, it's a matter of having things labeled out properly. So for instance, I'm looking, or I know I always go A, B, C in my angles. I know angle A is 78 degrees, and I happen to know side A. I know angle B, and I'm looking for side B. Okay. And then if I look at this, according to what I've got, I don't know angle C, nor do I know side C. Okay. However, if I really wanted to work at it, I could find angle C because I know these two angles add up to be 180 degrees. I'm sorry, these two angles have to be 138 degrees. And all three angles have to add up to be 360 or 180, excuse me, 180. So 180 minus 138 gives us then 42. So I do know the measure of angle C, but I'm not asked to find the side length opposite side C, so I don't have to worry about it. But in order for me to solve now, and again, hopefully by the time you get through this video, or at least definitely in class tomorrow, you won't have to do this every time, we have to set up proportions. And we really have a three-part proportion here. So the sine of angle A, well, the sine of angle A is 78 degrees, so it's the sine of 78 degrees divided by the length of side A, which is 8. Okay. Equals the sine of angle B, well, angle B is 60, over its opposite side, which was x. I don't know that one. That's what I'm looking for. And then the last one, sine of angle C, well, C is 42 degrees. And again, I don't know anything about C, so I'm just going to call it C. Okay. So this is our setup. Okay, sine of an angle over its opposite side equals sine of an angle over its opposite side equals sine of an angle over its opposite side. And they're wanting us to solve for x, which means I have to use this proportion to do that, or this ratio, or this fraction, however you want to think of it. So the trick becomes, which one do I use with this to solve? And well, we use the one we know both parts of, so we'll use these two together. So in class, what we will do is we will solve for x using these two guys together. Okay. Right. Now example B, same thing. I mean, really exact same thing. This gets to be very, very repetitive. Okay. In fact, for this one, it's a little different than the last one because when I look at the stuff to market, I don't know, we'll start with angle Q. Q is the lowercase angle. Here's angle Q. Its side's not mentioned, which means I don't really need to worry about angle Q. R, okay, I don't know its angle, but that's the side I'm looking for. So this is where we go back to that previous problem where we say, oh yeah, I forgot, all three angles have to add up to 180. So 37 plus 54 is 91. So 180 minus 91 gives us 89 degrees. That's the measure of angle R, 89. So now, okay, angle R on its opposite side. And then last but not least, angle S on its opposite side. So now I can set up my proportion. Sine of angle Q over whatever. I'm going to call it Q because I don't have a measurement for it. Equals sine of angle S, which is 54 degrees, over 8, because that's what S is opposite. And then equals sine of 89 over X. Okay. And then in class, when we go to solve this, I'm going to want to use, I'm looking for X. I need to know the one that has both of it with it, so I have to use these two together when I go to solve in class. Okay. All right. Okay. Now the next two, 2A and 2B, are really the exact same problems, so I'm not going to walk through those. Okay. Those are left to you to try to set up on your own. If you've got questions, again, come on in the next morning. I'll be more than willing to help you out. Now, the next one we're going to look at is the law of cosines. That's our next kind of theorem we're going to start through here. So I did A and B. Okay. Law of cosines. Now, the law of cosines, again, works with non-right triangles. These actually do work with right triangles as well, but it's easier to use SOHCAHTOA than. And it says when the law of sines cannot be used, the law of cosines may apply. It doesn't work like that. You just one or the other. It's kind of what happens. And the law of cosines works, and this is part of the things you have to cop down. The law of cosines works when you know two sides and the included angle. So we're talking about measured of two sides and the included angle. We go back, that was side angle side in earlier on in the year. Now, I'm going to block something real quick. So it's going to come back. So if you're using this to copy stuff and go, trust me, it's coming back. But what I want you to realize is with the law of cosines, it's the Pythagorean theorem. Okay, that's exactly what's actually going on. C squared equals A squared plus B squared. And then what happens is we just reorder these guys. With the with the Pythagorean theorem, C has to be the biggest side for C squared. Well, with the law of cosines, you say, I don't care what you do. You do A squared, B squared, C squared, put those on their own, that's fine. How we fix it is, there's this little what I kind of think of as correction term. And what it is whatever two sides, A and B, because again, lowercase letters are sides, whatever sides are on the same side together, it's minus 2 times those two sides together, times the cosine of the angle opposite the side you're looking for. So A squared plus B squared minus 2AB cosine angle C. A squared plus C squared, because I'm solving for B, minus 2AC times cosine of angle B. And B squared plus C squared equals, or minus 2BC, so again, those match, times cosine of angle A, I'm solving for side A. Okay. So it is actually the Pythagorean theorem, it's just kind of modified. And again, there's a lot of math going on in the background that we're not going to have to worry about. So let's look for our first example here. We're not going to solve this. It says solve for x. I'm just going to set it up when I'm solving. So, whoops, sorry, wrong button. So if you look at this one from the first example, okay, 3a, notice I don't have A, B, and C for side lengths. I don't. And that's because, to be honest, I don't want you thinking that way, even though that is the formula. What I prefer you go back to is the fact that you have to have, like, let's say I'm looking at solving for A. I'm solving for cancel. I think I just do this. Yeah, no color. So I'm solving for side A. Okay, in this case, let's say when I solve for side A, okay, I have to know side B and side C. Okay, so I have to know those two guys and the angle between them. Okay. So in this case here, when I'm looking to solve for a side, here's that side, angle, side. B, C, angle A. B, C, BC, angle A. If I were solving for side B, I would need to know, whoops, side B, or sorry, side A and side C, AC, angle B. So I'm solving for side B. And if I'm solving for side C, okay, it's A and B and C again. So for this one, that's all I have to do, is just set that up. So let's take a look. Okay. So I'm looking for this side. Okay. Well, do I know the two sides and angle between? Yeah, I do. I know those two. So what I can do to solve for x then is, this will be side squared equals a squared, I know b squared, whatever I'm going to think of it as, so 15 squared plus 19 squared minus 2 times 15 times 19 times the cosine of the angle between those guys, 125. Okay, so angle, side, I'm looking for this one. This squared plus this squared minus 2 times this times the cosine of that angle gives us side x. And again, we'll solve this in class. Same thing for 3b. Same exact thing for 3b. Okay, so I'm going to look to solve for this side here, which we're going to call side x. Okay, in order to do that, I need to know the angle opposite of it, which I do, and the other two sides around that angle, which I also do. So this guy will be this squared plus this squared minus 2 times this times cosine of 62 degrees. Okay. All right then. Yeah, so that's section 8.6. So again, in a minute here, a question will pop up saying, hey, did you understand this? And then we'll do tomorrow in class, we'll go through these and we'll solve.